AI philosophy, enabling humans to establish destiny for themselves and establish a mind for AI. In the author's view, large language models, LLMs, represent a deep reconstruction of human knowledge. Today, AI has clearly become both a tool and content, both content and rules, and both rules and agents. The value of a genuine AI product lies not in what it can do, but in what it has accomplished. Human roles have also shifted from controllers to macro orchestrators, directors. In the AI era, choice outweighs effort, judgment outweighs reasoning, planning outweighs execution, synthesis outweighs analysis, structure outweighs content, goals outweigh processes, and aesthetics outweighs deep thinking. Click the plus to follow this account for more exciting content. Large language models are one of the most revolutionary technological breakthroughs in the field of artificial intelligence in recent years. At their core, they achieve general processing capabilities for complex tasks through training on massive data and ultra-large-scale parameters. Based on deep learning architectures, these models can automatically learn high-level features and patterns from multimodal data such as text, images, and audio. Specifically, centered on advanced neural network architectures like transformers, they capture semantic associations through self-attention mechanisms, complete knowledge transfer via pre-training and fine-tuning, and optimize model behavior through alignment learning and reinforcement learning from human feedback, RLHF. The emergence has completely overturned the traditional AI paradigm of customizing models for single tasks, demonstrating strong generalization capabilities and emergent properties. For example, the GPT series has achieved performance in diverse tasks such as text generation, code writing, and logical reasoning that is close to or even exceeds human levels. The training of LLMs relies on distributed computing clusters and optimization algorithms, consuming enormous computing resources. However, their pre-training plus fine-tuning paradigm has significantly lowered the barrier to developing downstream applications, making them a critical infrastructure for promoting industrial intelligence. OpenAI's GPT series and Meta's LLMA are representative works in this field. Researchers are exploring more efficient training algorithms and architectures, such as DeepSeek's cost-effectiveness, ultra-low cost, and strong reasoning capabilities to reduce computing resource consumption while improving model accuracy and generalization. Additionally, to address data privacy and security issues, privacy-preserving technologies such as federated learning and differential privacy are being widely researched and applied. These technologies enable model training and optimization without exposing user data. Technological evolution is driving the reconstruction of social production relations. LLMs not only reshape content creation paradigms such as personalized text generation, intelligent customer service, and autonomous driving, but also rapidly adapt general knowledge to vertical fields like finance and education through transfer learning. In the future, LLMs will evolve toward multimodality, embodied intelligence, and specialization, while facing challenges such as high computational costs, data scarcity, and ethical controversies. With a dramatic improvement in the usability of LLMs and their approach to or even surpassing certain human capabilities, AI has clearly become both a tool and content, both content and rules, and both rules and agents. This breaks the traditional boundaries of technological neutrality, separation of governance, and fair subjecthood. In the author's view, current LLMs are essentially a deep reconstruction technology, not a deep thinking technology. They reconstruct human knowledge by first compressing, consolidating and refining massive amounts of knowledge into structured fragments, then reassembling these compressed and refined fragments into new statements, based on application requirements, through setting smooth conditions and continuous parameters. This process of compressing, breaking down, and reassembling can also be called encoding and decoding. It is similar to 3D reconstruction, where 3D mesh patches are first broken down and then reassembled into new shapes. For an illustrated explanation, see Chapter 2.3 AI's Reconstructionism. The development of LLMs will go through several important stages. Initially, LLMs are in the co-pilot stage, where AI acts as an intelligent assistant to humans. Its core value lies in assisting rather than making independent decisions, helping humans complete tasks more efficiently by providing suggestions and support. Output still requires human review and quality control. In this stage, detailed and clear prompts given to AI are crucial, as they guide the model's output similar to reciting scriptures or mantras. This has given rise to prompt engineering, the design, optimization, and adjustment of prompts to elicit optimal outputs from LLMs. Subsequently, LLMs enter the agent stage, characterized by breaking free from passive response and acquiring capabilities such as active tool use, environmental perception, and strategy optimization. These intelligent systems exhibit a degree of autonomy, reflection, and self-evolution, marking an important leap from the instrumental nature of AI to subjective thinking. With further improvements in automation, LLMs will develop into the AI worker stage, where agents can independently complete various mental and physical tasks like humans, replacing most human work in the future. The concept of agents can be traced back to the 1950s, 1970s, when computer scientists began exploring program systems capable of autonomous task execution. In the 1980s, as traditional centralized AI methods revealed limitations in complex environments, agents became a key research focus. As a systematic theoretical concept, an agent is defined as a computational unit that can autonomously perceive the environment, make decisions, and take actions. For example, in autonomous driving, agents achieve autonomous navigation and obstacle avoidance through real-time perception and decision-making. This concept laid the foundation for modern AI technology and plays a vital role in research on robotics, autonomous systems, and multi-agent systems. Agents are not intended to be completely independent of human control, but pursue a state of human-machine coexistence and integration. A genuine AI product is judged not by its capabilities, but by its practical outcomes, not by what you ask it to do, but by what it accomplishes for you, especially completing an end-to-end task process with a closed-loop delivery. Only when you move beyond the human-controlled machine mindset and redefine tasks, assign trust permissions, and establish collaboration mechanisms can you step into the realm of human-machine integration. Notably, current AI models perform well in single-round conversations, but experience sharp performance drops in multi-round interactions. This is fundamentally due to their lack of true internal consistency and self-awareness. Therefore, we should not be overly demanding of their current capabilities, but focus on maximizing practical outcomes. The development trend of agents is from LLMs to tool use, then to workflow orchestration and task delegation, ultimately forming an intelligent ecological network. Treating AI systems as production lines rather than one-time question answering requires building a complete operational structure spanning organization, processes, and tool chains, and supporting multi-agent collaboration, parallel operation, fault recovery, state tracking, and full traceability, debuggability, optimizability, and iterability of all behaviors. Each step requires clear responsibility division, feedback mechanisms, and automated upgrade paths. Human roles shift from controllers to macro orchestrators, directors, responsible for designing agent responsibilities, interfaces, and trust boundaries. LLMs are no longer just response tools, but path planners. Future AI operating systems will be task scheduling hubs, oriented toward results, not what they can do, but what they have accomplished. Ultimately, agents and humans will achieve a harmonious state of human-machine integration, unity of man and nature. In the AI era, LLMs can provide massive information retrieval and generation. The most important ability for humans is no longer analytical or reasoning skills, but judgment, choice, planning, architectural thinking, synthesis, and aesthetics, that is, first imagining and planning, providing insights and questions, then selecting and judging from multiple analytical solutions offered by LLMs, and proceeding to architect and synthesize on this basis without the need for extensive manual analysis and thinking, since human rationality is negligible compared to AI's almost unlimited computing power. As the saying goes, choice outweighs effort, judgment outweighs reasoning, planning outweighs execution, synthesis outweighs analysis, structure outweighs content, goals outweigh processes, and aesthetics outweighs deep thinking. I am Wu Huaiyu, a PhD from the Chinese Academy of Sciences and a postdoctoral fellow from Peking University and the founder of AI Philosophy. For more detailed information, please refer to the complete version of this book. In addition to this short video, you can also click on my avatar to view more long videos.